It's not.
Okay, so are you able to see my screen?
Yes.
Okay, so till yesterday what we have done, like security profiles. In a security profiles we almost covered every profile, like URL filtering or application control, DNS control, or IPS signatures, antivirus filtering. We control all this, or we covered all these topics, right? Yeah. Today we will move to next topic. Our next topic would be VPNs, virtual private network, or a site-to-site VPNs we call it. So why do we need a VPNs? Yeah, any question?
No, I'm
Okay.
okay.
Yeah. So let us understand why do we need a VPNs now. For example, I'm having the environment. This is my firewall. Beneath my firewall, I am having a switches. It can be a core switch, it can be your DC switch, it can be any switch, right? Then from a switches, I am having more switches connected. Okay. Here also I would be having some type of switch connected. This assume my L3 switch. These are my L2 access switches. Beneath my access switches, I would be having a users connected, right? Now everything is working fine. I am having a internet connected. Here would be my internet. Okay. So now when the users wants to go to internet or anything, everything is working fine. This is my branch 1, or you assume this is my data center. Okay. My servers, my users, everyone wants to go to internet, they will be able to go to internet using a internet link or ISP service provider, right? Now assume at the same time I am having another branch. Okay, this is my DC2. 1 minute, hold on. I am having another branch now. This is my branch firewall. Okay, this was my DC firewall. This is my branch firewall. Beneath my DC branch firewall also I would be having some type of switches. Maybe it is a small branch. I am having L2 switches. Then I would be having some type of users connected, right? This is my user, this is my user. Over a branch also I am having a internet link. Everything is working fine, correct? Now a branch also able to go to internet, a DC also go to internet, and suppose I am having some type of switches. Here I am having another switch, I call it a DC switch. From a DC switch I am having some type of server. It can be FTP server, DNS, DHCP, anything server can be possible, right? Now assume from ISP to ISP, for sure there would be a type of connectivity available, because ISP to ISP there would be public network communication would be available. Now the problem or the requirement is these users in my branch wants to communicate with the servers in my data center. Okay, they would be usually a requirement that my branches or my locations should be communicating with each other, right? Over my DC I may be having some type of FTP server also available. Okay, maybe I am having some type of DHCP, some type of DNS server, or I may be having a AD server available in my data center, right? Usually this type of things available in our data center, correct? And our branches would have need to have a communication with our AD server, DNS, DHCP, FTP servers and all for reachability and all, right? But the problem again, beneath this particular site, this would be private communication, right? Private network, which is assume 192.168.10.0/24. This also private communication, which is again 192.168.20.0/24. Okay, so a private communication cannot be forwarded or cannot be routed over the internet, right? Internet usually it is a public network, right? From here to till here, this is all public network. we cannot have a communication, or we cannot route a private IP addresses over the internet, right? Because ISP will not be able to route, or ISP will not be able to forward the traffic if he sees a traffic with the private IP addresses. Or internet can be routed only with the public IP addresses. Correct? Now how do we do a communication between our data center and between our branches? It can be one branch, it can be 100 branches available. Then we need a communication between our data center and our branches, right? So now let us see what could be the solution. There are multiple solutions available for this. Sorry. Now see, first thing, I may not be having an internet link. Okay, I need a communication, or sorry, okay, internet link, let it be internet link available. I may need another link, a private link from my data center to my branch. It would not be a public link, it would be a private link. Generally a private link, we call it a MPLS or a point-to-point link, right? So we ask a provider that please provide us a private link for our branches or our locations communication. Then we need to do a routing on top of private link for a communication, right? This is one solution, but this solution is very costly. We cannot be reliable on this solution. It is very costly, and if we are having like 50 branches, 100 branches, and everywhere we need a private link, it would be very costly for our business. Okay, then we cannot use a private link in this scenario. So now let us assume we are not using a private link, we need to use a public link only. So over a public link, what we need to do, we need to create a virtual tunnel from our public IP. This we would be having a public IP, and other side of the firewall also we would be having a public IP. So over the public IP addresses of our firewall, we need to create a tunnel from one firewall to another firewall. We need to create a tunnel. Okay, then we need to tell a firewall, we need to tell our firewall, or we need to configure the firewall in such a way, if source is, suppose we say a DC subnet and destination, okay, a source is a DC subnet and destination is branch subnet, then instead of sending this traffic to a public internet, send this traffic to a tunnel interface. Okay, and same thing we will tell to this firewall also, if a source is a branch subnet and destination is a DC subnet, then send this traffic to our tunnel interface. Okay, so this traffic would be forwarded to a tunnel instead of going directly over a open internet communication, and traffic will, suppose the traffic came from this particular branch via this PC, it will come to firewall, and firewall will check, okay, what is the source, what is the destination, okay, this traffic need to be going to a tunnel interface. Instead of sending it over the open interface or open internet interface, there would be a tunnel interface created. The traffic will come from this particular tunnel and it will exit from a firewall. Okay, is it clear?
Yes, clear. What happens to the tunnel when no traffic is going through it? Does it remain up, or does it
there is a time
go down?
available. There is a time available. The tunnel would be up and running. If the time done, the tunnel would be going down. Okay.
Okay.
Yeah. And there are options available that you can do. You can configure a firewall in such a way. Not only a firewall, any device. You will say, okay, keep on monitoring the tunnel and keep the tunnel up and running. You will say, like small ping messages you would be continuously sending from one firewall to another firewall. So the tunnel would be always up and running. Okay, this type of things we can do to do a tunnel monitoring. Then we'll say, okay, if we don't get a specific ping replies in a specific second, then we will shut down the tunnel. We can do that type of optional configuration. Okay, so after this, now 1 minute, hold on, just give me 1 minute, guys. So now the traffic, even if it is a tunnel, the traffic is going from my internet, right? actually the tunnel is created between a public IP address. This is a public IP, this is a public IP, and we told the firewall, okay, this would be a source IP, this would be destination IP, with whom you need to create a tunnel. But the tunnel actually going via actual underlay, we call it underlay, is going via public internet, right? And over the internet, if someone is doing a packet capture of my packet, they can read whatever I am sending from a branch to DC or DC to branch, right? That would be again not safe for our environment. So there are predefined security measures available in a protocol. We call it a IPsec tunnel. Okay. There are two protocols available, like IKE version and IPsec version. What these protocols will do, they will give us authentication, they will give us integrity, and they will give us encryption. So what happens generally? Suppose this is my firewall, a DC firewall, then I would be having another firewall. This would be my branch firewall. Okay. So then I would be having a service provider. Okay. Now when the traffic is going, okay, so this is my public IP, this is again my public IP. When the traffic needs to go, or a firewall need to build a tunnel between each and other firewall, right? Suppose this is firewall 1, this is firewall 2, they want to build a tunnel between each other. So first they will have authentication. A firewall will authenticate another provider or peer, we call it a peer authentication. Okay. So what happens, this firewall will check, okay, what is the peer configuration available, do I have a peer IP available with me, do I have, if whatever authentication methods we are using, authentication method can be a PSK password or it can be a certificate. Authentication method is passing between each other or not. If it is not matching, we will not bring the tunnel up and running. Okay. So that means authentication, we will try to authenticate our peer. How we authenticate whenever we are going to any website? Suppose I am going to gmail.com, I need to type my username and password, right? Then Gmail will authenticate me. Similar to that, when we are trying to build the tunnel up and running, a firewalls will try to authenticate each other using the peer IP address, whatever peer IP address configured in the tunnel configuration, then password or a certificate. Okay. Then encryption. Encryption means after a tunnel came up. Now suppose there is a tunnel came up, then a firewall, what he will do, before sending a traffic to this particular tunnel, he will encrypt the data. If someone in the middle is doing a packet capture also, he cannot read what is happening into our data. He can just see a hash algorithms, but he cannot read actual data. The data would be encrypted with the hash algorithms. Okay. So if someone is even doing a packet capture over the internet of your traffic, they cannot read whatever it is happening. So whenever the traffic is encrypted, suppose this firewall is sending a traffic, he will encrypt the traffic, and only this firewall can decrypt the traffic when the traffic is going out. They will decrypt and he will send the traffic to a user. Now when the user is sending return traffic, again this firewall will encrypt the traffic, and only this firewall can decrypt the traffic. No other people can able to encrypt or decrypt the traffic. Okay. Is it clear?
Yes, clear.
Okay. Then we would be having another thing, we call it a integrity. So what happens? Suppose someone even did a packet capture to your data, right? In the between. So usually the data would be traveling in the zeros and one numbers, right? And someone is trying to change a 0 number to 1 and 1 number to 0. They are doing a malfunction with your packet, right? They don't know the actual data. They are not able to read the data, but they are trying to change the binary tables of the data. Then data would be having a machine would be, suppose I am sending a name. In my data I am sending a name as a PDF, and someone did a packet capture, they did a hash algorithm change, instead of PDF they send a FTP. Then firewall will read the wrong data, right? So integrity means whatever this firewall is sending, this firewall will check. If someone did a hash algorithm changes in the middle, someone did a packet capture and tried to did a malfunction with our packets or not. This is called the integrity check. Whenever I am sending a data, I will do some hash algorithms and I will send the same hash algorithm, and another firewall will check, okay, if someone did a packet capture, they have tried to modify anything in the data. If they have modified, I will not accept this traffic, I will reject this traffic. Okay, so these are the three main pillars of our IPsec tunnel: authentication, integrity, and encryption. Okay, is it clear?
Yes, clear.
Okay, then in our tunnel we have two main phases: phase 1, phase 2. Okay, so what is a phase 1? Phase 1 is generally we call it a management traffic or management tunnel. Then phase 2 we call it a data tunnel or actual data traffic. So what happens in a phase 1? A communication will happen between a firewall to firewall. Okay, in a phase 1, firewall to firewall, they try to authenticate each other, they try to create encryption keys and all between the firewall to firewall. There would be no actual user traffic would be going in a phase 1 tunnel. Okay, then in a phase 2, the actual user traffic would be flowing using a phase 2 tunnel. Okay, suppose now I am having this user, again I am having user also here this side, right? So before coming or before the user sends a traffic to another user, firewall will bring a phase 1 up and running. A phase 1 encryption keys and authentication would be done using a phase 1. Then when the actual traffic need to go from user to user, there would be a phase 2 tunnel would be coming up in a firewall. Okay, so usually whenever you configure IPsec or side to side VPN, we would be having two tunnels in our firewall: phase 1 tunnel and phase 2 tunnel. Okay, is it clear? Okay, so now let us see. So if you see, an IPsec side to side VPN focus on two major negotiations: phase 1, underlying network requirements that glue them together; phase 1, the management tunnel or the handshake. This will happen usually between the firewalls, so the firewalls can safely talk to each other and decide how to protect your data. Phase 1, establish secure management channels, so the firewalls can safely talk to each other and decide how to protect your data. So in a phase 1, what are the main parameters? Authentication. Both sides must agree to pre-shared key or a digital certificate. Either you can go with a pre-shared key for authentication or you can go with a digital certificate also. Then we would be having an encryption algorithm using a phase 1. So encryption algorithm can be your AES 256 or SHA 256, or you can use any other encryption algorithm also. Then we need to have a Diffie-Hellman group. Diffie-Hellman group is for like once you create a phase 1, once you have encryption keys and all, you would be having one, we call it a secret code. Okay, this secret code should be valid for a specific timer, right? So a Diffie-Hellman group will help us to decide what is a timer the secret code should be there. After the timer is exceed, again the communication would be established and again the timer would be enabled. Okay, so Diffie-Hellman group means for creating a secret code, like how we did the SSL communication, right? In SSL communication between a server and a client, there would be SSL communication happening, and using a DH group, they will create a secret code, right? Secret code for encryption and decryption of data. Okay, and this encryption and decryption would be valid for how much time? This would be happening with the help of this, right? So use DH group is nothing but to create a secret code and to help us like the data should be, or this particular encryption and decryption key should be valid for a specific timer. After the timer is expired, again you need to have a new secret code. Okay, so these are the main parameters like encryption, hash algorithm, then Diffie-Hellman group in our phase 1. Okay, then again in a phase 2, the data or actual payload, the payload, once the management tunnel is up, phase 2 creates the actual tunnel that a user data travels through. So in a phase 2, the actual tunnel would be created which would be used for user data encryption and algorithms. Okay, so even in a phase 2 also you need to have an encryption key, and in a phase 2 DH is optional. If you don't use a DH, the DH would be used from a phase 1 only. Okay, Is it clear? But the encryption keys would
Is
be
it?
required in
Yeah.
phase 2 also.
But the
Mhm.
Diffie-Hellman group, is the group number default, or is it?
No, you can change it. I just gave an
Okay.
example of group 14.
Yeah.
You can change it to group 5, 20, anything you can do it. Okay? Yeah. Now, let us see the practical thing. 1 minute. So now, what we have understood, what is the practical requirement for tunnels to come up? 1 minute. Phase 1, authentication, which is a password or a certificate, right? Then encryption, which is AES or a DES, anything you can use. Then hash algorithm. Hash is nothing but your MD5 hash or a SHA hash. Okay. Then DH group, Diffie-Hellman group, which can be anything. Suppose I am using group number 5. This I am using at a firewall 1. So at a firewall 2 also, I need to use the same parameters. This we call it a phase 1 parameters or phase 2 tunnel parameters. Okay. 1 minute here. One minute, guys. Okay. Suppose in a phase 1, I am using a password based authentication. Then at a firewall 2 also I need to use a password based authentication only. I cannot use one side of a password and another side a certificate based authentication. And even a password should be matching at both the sides. Then encryption key, here suppose I am using AES 256. Then other side also I need to use AES 256. And other side if I am using AES 128 authentication, the authentication or encryption would not be matching. The firewall or phase 1 tunnel will not come up. So usually the parameters, we call it a parameters, should be matching at both sides. Okay, is it clear? And similarly, even in your phase 2 also, a parameter should be matching at both sides. Okay, if a parameters are not matching either of the side, then your tunnels will not come up and your traffic will not flow between your side to side communication. Okay, is it clear?
Yeah, clear. When the tunnel is built, which is it UDP port that is created for this, or used for
Will come to
the
that.
established? Okay.
Okay, so now let us go to again theory. So encryption, I'll share you this particular document. You can go through this. What is encryption? What is authentication? What is integrity? What is Diffie-Hellman group? Okay. Then IKE version 1. Version 1 is an outdated version which is no more used because of the issues in a version 1 because of vulnerability like online brute force attacks was happening in a version 1. Okay. So we'll not discuss much on a version 1. We'll go with a version 2 now, which is majorly used everywhere now. So IKE version 2. In a version 2 we are having like 4 messages when the traffic is going. IKE is nothing but a phase 1 communication. Okay, in a phase 1 communication we are having a 4 messages when one firewall wants to communicate with other firewall, right? Suppose this is firewall 1, this is firewall 2. When they want to bring the tunnel up and running, they will have a 4 messages shared between each other. Okay, first message we call it IKE initiation message or sent by initiator. I want to talk, here is my menu of encryption, hash algorithm, DH group and random number they will send. key action. It includes the diffie element group instead as the message is unencrypted. Means a first message would be unencrypted. A firewall. Suppose I am initiating, I will say SA initiated message. Okay. This will be sent to another firewall. Then second firewall will reply. What he will reply? IK initiate also he will reply, or this would be replied from a responder. I agree to your AES 256. Suppose I am sending whatever encryption in DH group. Second firewall agrees that. Then he will say I agree. If you don't agree or these parameters are not matching, he will say I don't agree. We cannot build the tunnel up. Both agrees to a second message. Then a responder will again reply with authentication. In authentication he will say like these are my hash, this is my pre-shared key and all. And even at the same time he will say I want to use, this is our private IPs. Suppose this IP is a branch particular DC subnet, and at the same time he will say this is my private subnet, I want to communicate with you. Then fourth firewall will reply, second firewall will reply okay, I accept your pre-shared key, I accept the traffic selector and all. Okay, then a phase 2 will come up. Usually in IK version 2 what happens, let us see. First let me go through your IK version 1 also once. Why do we have the issues with IK version 1? First thing, it is vulnerable now. Second thing, timers. In IK version 1, the DH group will create some timer, right? It cannot be automatically refreshed. There are some issues in IK version 1 and we need to manually refresh the timers. That was the one issue. Then a tunnel process. In IK version 1, in a phase 1, we will be having either 6 messages or 3 messages based on the mode. Okay, there were 2 modes, a main mode or a quick mode. In a main mode, usually we will be having a 6 messages. In a quick mode, we would be having 3 messages. Then they would be separate 3 more messages in a phase 2. Okay. After phase 1 comes up, firewalls will try to communicate with each other for a phase 2 communication. This was usually happens in a IK version 1. Suppose this is my firewall and this is my firewall. Okay. A firewall 1, a firewall 2. He will send a 6 messages. Sorry, he will send a 3 messages. This firewall will send a 3 messages. Total altogether 6 messages for a phase 1 communication. After a phase 1 came up, this firewall will send a message. This firewall will send a message, and this firewall will send a message for a phase 2 communication. Okay, they will try to talk to each other and try to match the parameters and bring the tunnel up and running. Okay, this was usually in a phase IK version 1, which is very slow and it has some vulnerabilities, so nobody is using that now. If companies are using, they are in the planning of migrating to IK version 2. In version 2, we only have 4 messages. With the help of 4 messages, both phase 1 and a phase 2 tunnel comes up. There is no separate communication for a phase 1 traffic or a phase 2 traffic or a phase 1 tunnel or phase 2 tunnel. With the help of 4 messages, both the firewalls will come up or both the tunnels will come up. How does it happen? Let us see. Suppose this firewall send a message. Firewall 1 is sending first message as an initiator. In an initiator, what he will say? This is my DH group, this is my encryption key, this is my hash algorithm, and so on, and this would be sent to firewall 2. A firewall 2 will reply accept message. He will say okay, I accept so and so hash algorithms and all, and I take this in my authentication. Okay, this was second message. In a third message, he will say this is my password and this is my selector. We call it like a selector or interesting traffic. Interesting traffic is nothing but a phase 2 communication, which means suppose behind this firewall I am having one subnet. This is my DC subnet. Okay, 1 minute, hold on. This is my DC. This is a subnet 192.168.10.0/24. Here also I am having some type of subnet 192.168.20.0/24. Okay. So interesting traffic means this firewall will say my source would be 10.0 and my destination would be 20.0. I want this to be a selector, and whatever my preset key and all, password and all, this is my third message I am sending to you. Okay. If you accept this, please send me a accept message with the selector and a password key. This firewall will say, suppose on this firewall you have not configured interesting traffic, then a phase 2 tunnel will not come up and only a phase 1 tunnel would be up and running. Okay. So a firewall will say, I don't accept this interesting traffic, I don't want to build the tunnel up and running. Okay. Or else if he accept interesting traffic, he will say password is accepted, selectors or traffic selector is accepted, we can build the tunnel up and running. So with the help of 4 messages, both phase 1 and phase 2 will come up for you. Okay. Same thing you can see here. With the 4th message, I verify your proof. Here is my identity and my proof that I also know the key. I accept your traffic selector. Then phase 2 tunnel will come up with the help of traffic selector accepted between both the firewalls. Okay. Is it clear?
Yes, clear.
Okay. Now comes another topic or the point you asked. What port number a firewall will use? Right? When this firewall wants to build a tunnel with another firewall, the default port number is UDP 500. Okay. If there is no NAT device in between. Now assume the environment. Okay, we'll go here. Or 1 minute. Okay, this environment will go. Now assume before my firewall, my ISP is directly connected to my firewall. Here my ISP is directly connected to my firewall. To bring the tunnel between this ISP to this firewall to this firewall, there is no NAT device in between, right? So the default port would be UDP 500. If my ISP is not directly connected on my firewall, there is some router in between. Okay. Then ISP link is connected on router, or router is connected to firewall. Now the router is acting as a NAT device, right? In this case, instead of port number 500, we would be using a port number 4500 for a tunnel to come up. Okay. Is it clear?
Yeah, clear.
Okay. So now let us go to lab environment. We'll see how does it works. And even I'll share you the theory guide. You can go to a theory of IPsec also.
Okay, great.
I'll just close this 1 minute. Close lab. Just a minute, hold on. Okay, we'll use this particular lab. We don't need this PC. We don't need this PC. This is also not required. This is also not required. Then this is also not required. Done. We will go with the one ISP only. ISP 1 we are having. We don't need this for now. Delete this. Delete this. Delete this. We are having one firewall as our DC firewall. I'll name it as a DC firewall. Okay. 7.0.17 I will take it. Wipe all the configurations and the new configuration. Let us power on this, power on this, power on this. Then I will take another firewall, Fortinet 7.0.17 branch firewall. Okay. Done. 1 minute. I'll change the icon to firewall to be done. Connect this also. Oh, sorry. Then I need one Windows PC, Windows 11. Okay, done. Desktop branch PC. Okay. So this would be our lab topology. To connect to this port number 4. At the same time, I will change it to sir. Done. This side I would be using 101.1.1.0/24. Firewall side we will use .1. Router side we will use .100. Okay. Is it clear?
Yeah, clear.
Okay. We'll try to prepare this topology. Then we will configure a tunnel between our router and our firewall to firewall, DC to branch. Let me configure router quickly. At the same time, let me open a Windows PCs also. We'll configure a lab topology and we'll keep it so we can do it in the meantime later in the next class, right? Okay, this is our DC PC. Branch PC is powering on. Let me open this again. Okay, what I'll do, I'll configure this everything and we'll connect again next class. Then we'll do a lab environment. Okay. Is it fine? Because
Yeah,
we need
okay.